Welcome to Study Loop.
Okay, we had the reaction A plus B goes to C plus D. And we've also been given data about the initial concentrations of A and B and what effect that has on the initial rate of reaction. When A is at 0.1 molar and B is at 0.3 molar, the initial rate is 1.5 times 10 to the negative fourth moles per second. When A is doubled, notice it's twice as much as A, and B is held constant at 0.3 molar, then the initial rate goes to 3 times 10 to the negative fourth moles per second, i.e., the rate doubles. Let's make a note of that. Okay, and then when we keep A the same as in our previous reaction, but double the starting concentration of B, what happens to the rate? It goes to 12 times 10 to the negative fourth moles per second. And what's the mathematical relationship between 3 and 12? The rate quadruples. I'm just going to write quad. Okay. So when A doubles, double A initial means rate doubles, or 2 times. And when we double B initial, the rate quadruples, or 4x. So what is the rate law of this reaction expressed as a function of reaction concentrations? That is, rate as a function of A and B equals, okay, now what we're supposed to do is use this information about the doubling of A leading to the doubling of rate to find a mathematical relationship that would equate to doubling a number, such as A, and having the rate double, right? So consider rate equals K, some constant, times A, meaning that it is linear in A, or an option might be rate equals K times A squared, meaning it's quadratic in A. And what we're supposed to notice is that, let's say we double A, right? And we say that K, and then we do 2 times A. And what we've been told is when we do that, the rate doubles. We get 2 times rate. Okay, well, that follows with being linear in A, because 2k times 2 times A equals 2 times the rate. That makes sense. But it wouldn't follow for the square case, because if we said k and then squaring our doubling of A, 2 times A squared equals 2 times the rate. Is that true? No, right? Because we know that 2 times raised to the power of 2 would give us k 4x, right? Doubling the 2, a squared, equaling 2 times the rate, right? So if we see that doubling an component doubles the rate, then we know that it is linear in that component and not squared in that component. But notice that in the case of B, when we doubled our B, the rate quadrupled. Well, that's exactly what we saw for us, our hypothesis about A being quadratic, or the rate being quadratic in A, right? When we multiplied A by 2 and then squared that quantity, we got 4 times the concentration of A, right? And if this were the case of B, that would be like saying K times 2 times B equals 4 times the rate. Is that true? Or recall that this is squared. Yeah, because then we would get 4x times b squared being our original law, which would be 4 times our original rate. Right? So then we can determine that we are linear in A, and quadratic in B, or that our rate is equal to K, our rate constant, times A to the first power, which we typically would not write, times B to the second power. Or answer D.